Hi, so we are Team 2 and our project is CollabStream, which is basically a distributed video streamer. A brief recap of the motivation. Our main issue with the current streaming services are that they are hosted on the internet, and hence internet connectivity plays a big role in these services. Our solution is to move to the LAN. And current LAN solutions such as VLC Player are centralized streaming solutions and hence inherit major issues such as a single point of failure and server overload. So what we have implemented is a distributed streaming application for LAN. Our application does video streaming, load balancing, and is fault tolerant. Let's go through a brief system design overview. So we have a DNS which is used for bootstrapping and master failover, an overall ring topology, a distributed hash table to maintain the data, and streaming failover capabilities. So DNS bootstrapping. So let's consider this scenario over here. Node 4 is the master node in the system right now, and node 5 is a new node who wants to join in. So message 1 sends a request to the DNS asking him for the master node's IP address. Message 2 is the response. 3 is the actual message to node 4 asking to join the network, and 4 is the response from node 4 saying that yes, now you have joined the network. Let's take the case of bootstrap failover now. So here we have node 4 who was the master and has now gone down. So as you can see over here, node 5 tries to connect to node 4 but does not receive a response. And node 3 over here is in charge of checking if node 4 is alive right now, and he sees that node 4 has gone down. Because of that, he updates the DNS and promotes himself as the new master. As you can see now from message 3 and 4, the DNS sends back the new updated master IP address, and node 5 connects to node 3 now. So we have a overlay ring topology out here. Basically, in this topology, each node takes care of his neighbor. This is done through a basic heartbeat and acknowledgement system. So like for example out here, node 1 sends a heartbeat and node 2 sends back an acknowledgement. This is how nodes keep track if one has gone down or the other not. We use a distributed hash table. We have used a library to implement this. The data that has been stored in the DHT is the machine list, the node uploading and movie mapping data, the node's current load, and the running system running stream mapping of the system right now. Let's take the scenario of streaming failover. Consider this. Node 1 is streaming a video to node 4. Also, node 2 has the exact copy of node 1's video. Now, node 1 goes down. Node 7, who is in charge of maintaining the heartbeat mechanism with node 1, notices that node 1 has gone down, and also sees that he was streaming to node 7. He also notices that there's a copy of that video at node 2 and requests node 2 to continue with the streaming. As you can see, now node 2 now starts streaming to node 4. Our user interface, we have two main user interfaces. One is the main GUI itself, which allows the user to see the system state, to upload movies, and to request for a stream. The second interface is a media player, which basically shows the video stream itself and has basic media player capabilities such as play, pause, and seek. We faced several challenges while actually developing this project. The first major challenge was learning how to use Python properly. We chose Python because it was easy to use somewhat, and there are tons of libraries available for it. The main problems with that was we had to choose, first of all, Python 3, and a lot of the libraries had to be ported to Python 3. Another issue was how to implement locking, multi-threading, network programming, and object serialization all in Python was another challenge. GTK GUI integration, which is basically the GUI library, to be integrated with GStreamer was another issue. We used the GStreamer streaming library. Basically, this supports rich video formats and is a very clean design to use. However, there were many issues along with that as well. Key being the lack of documentation of how to use it in the first place, and our own lack of knowledge in multimedia processing, such as how to mux video and audio streams. The next challenge was the distributed hash table itself, how to actually put our theory that we learned in class into practice. The challenges out there were how to understand and modify the existing DHT library and adding interfaces to it. Another issue was concurrency with it and how to implement load balancing. Finally, video streaming failover was another challenge. Since detecting node failure, who should detect the node failure, and how to start a new streaming service from the current position that the client expects it to was a major issue. Teamwork. We learned how to actually manage ourselves as a team. The major problems with that was how to distribute work based on individual schedules. We found that frequently meeting, at least in email if not in person, was one of the solutions. So in the end, we learned a lot from this project. It helped us understand real-world issues in distributed applications, and we learned a lot of new technologies such as Python 3, how to use multimedia streaming at a basic level, and implementing and using distributed hash tables.